Alright, this is the third page of worksheet 7B, the key, and this is the page where we graph quadratic functions. And I want you to note that number 13 and 14 are both starting off in standard form, and so we're going to use the completing the square process to convert those into vertex form and find these things. And then the 15 and 16 are already in vertex form, so we'll start off knowing the vertex of those. So I'm going to put this sleeve over the right side of the page here, the opposite side of the page that I'm going to work on, so I have more space to work. So for number 13, this y equals x squared plus 6x plus 7, I'm going to complete the square on these first two terms. So I'm looking at this trinomial, and then I have the plus 7. And of course I have to subtract out whatever I add here. So this is going to be y equals, and a is obviously 1, x plus 3, quantity squared, so 3 squared is 9. I just added 1 times 9, so I'm going to subtract 1 times 9. So this is a negative 2. So we get a vertex at negative 3, negative 2. The axis of symmetry goes through this vertex, and it's a vertical line at x equals negative 3. This a is positive, so this parabola is going to open up. So I'm just going to sketch in negative 3, negative 2 on my graph as the vertex. I'll dash a red line in here for my axis of symmetry. Okay, and now I know that the vertex is going to open up symmetrical about that point, so I'll look for a few other key points. I want to talk about let's talk about the minimum value is negative 2. My domain is always all real numbers with a parabola that opens up or down. My range, I'm never going to go below negative 2, so values will always be above, greater than, or equal to negative 2. So let's look at the y-intercept first before we look at the x-intercept. To find the y-intercept, I set x equal to 0 and solve for y. Well, if I take the original equation, x squared, and I make x equal to 0, these first two terms cancel out, and I just get y equals 0 plus 0, plus 7. So y is 7. So in making a little xy table here, so when x is 0, y is 7, so that's going to be way up here somewhere. So I would be putting a point up here and reflecting it, somewhere back up in here. So anyway, that could give me points if I scaled my axis differently. The other thing is I want to find the zeros of the function, which is another word for the x-intercepts. And this is, of course, where we set y equal to 0 and solve for x. If I'm below the x-axis and opening up, I'm going to cross it in two places. So there's going to be 2 zeros. But what I do is I just take I'll take the equation in this form and set y equal to 0 and solve for x. So adding 2 to both sides. And then I take the positive and negative square root of both sides. So this is going to be x plus 3, I'll move it to the left, is equal to the positive or negative square root of 2. So x is equal to negative 3 plus or minus the square root of 2. So negative 3 plus the square root of 2, negative 3 minus the square root of 2. So let's look at what that would be. Square root of 2 is approximately 1.4. So negative 3 plus 1.4 is going to be at about negative 1.6. And negative 3 minus 1.4 is going to be at approximately negative 4.4. So I'm going to say negative 1 6/10 is going to be right about here, and symmetrically negative 4.4 is going to be about here. So that's going to give me enough to sketch a smooth curve. And I know I would go off of this particular page, but go through some points up here. So anyway, on the graph, I would probably look about like so. Okay, so now let's do number 14. With number 14, I'm going to complete the squared, put this in vertex form on these first two terms. So I pull out a, which I can see is negative 2, and then I would have x squared minus 4x plus blank to complete the square. Move my minus 6 out here. So right now I'm equivalent to what this is, but if I'm going to add something here, I have to subtract it out again. This will be x minus 2, half of negative 4, quantity squared. When I square negative 2, I get 4. I just added negative 2 times 4, which is negative 8. So negative 6 plus 8, this is going to be a plus 2. So starting again, my vertex is going to be at 2, 2. My axis of symmetry is a vertical line that goes through that vertex at x equals 2. I'm going to stop right now, 2, 2. This is going to open down, isn't it? Because A is negative. So my axis of symmetry is going to go through x equals 2. And that's going to be the maximum value that I hit. So my maximum value is at where y is equal to positive 2. And my domain and my range, y is never, I'm going to be opening down like this, y is never going to be above 2, so y is less than or equal to a positive 2. Okay, so let's do a little xy table. My y-intercept, where I cross the graph down here, if I set x equal to 0, then just looking at the original function, if x is equal to 0, so let's go y-intercept, y equals obviously negative 2. What happens every time is those first terms just zero out. When x is 0, y is negative 6. So 0, negative 6 is going to be in our graph, and then I can reflect that. This is 2 to the left of the axis, and I can go over 2 to the right of the axis and pick up a point here. And then my zeros of the function, which are my x-intercepts, I set x equal to 0 and solve for y. If I'm opening up, I'm obviously going to cross this x-axis twice. There's going to be 2 of them. So I'm going to, in this form of the equation, set y equal to 0 and solve for x. So subtracting 2. Dividing both sides by negative 2, I get a 1 on this side is equal to, so taking the positive and negative square root of both sides, I get x minus 2 is equal to positive or negative 1. So x is equal to 2 plus or minus 1. So 2 plus 1 is 3, and 2 minus 3 is 1 is 1. So I get my zeros of 3, 0, and 1, 0. So 1, 0, and 3, 0 is where I'm going to cross the axis line. So, or sorry, not the axis line, the x-axis. So my parabola is going to look like so. All right. So I'm going to take another sheet of paper. Whoops. And, well, maybe I don't need another sheet for the bottom ones because I've already got these in vertex form. So if number 15, the vertex is at -3, 2. So -3, +2. A is negative, so this is going to open down. So we can see that we will have two x-intercepts. So answering all the questions that we need to answer about this, the axis of symmetry is at x equals -3. We're opening down. What else do I need? The max value is at +2. The domain is all real numbers. The range is opening down, so y will never be above 2, so less than or equal to 2. And then let's look at the y-intercept. So for the y-intercept, if I set x equal to 0 and solve for y, I'll just do the work up above here. If I set x equal to 0, y equals -1/2 times 0 plus 3 squared plus 2, I get, this is 9, -9/2 plus 2, which is 4/2. I get -5/2. So -2.5. So at 0, -2.5, which is right about here, I get a point. So 1, 2, 3, 1, 2, 3. Reflect that over to the other side. And then my x-intercepts, I'm going to set y equal to 0. I'll have 2 zeros. And solve. So I'll do that down here. So 0 equals -1/2 times x plus 3 squared plus 2. So subtracting 2. Multiplying both sides by -2. Yes, okay, so I'm going to get a +4 is equal to x plus 3 quantity squared. So x plus 3 is equal to the positive or negative square root of 4. So x plus 3 is equal to positive or -2. So x equals -3 plus or minus 2. So rational roots again. So -3 plus 2 is -1, and -3 minus 2 is -5. So -1, and symmetrically across from it, -5, 0 are my roots. Okay. And then the last one I'm going to do is number 16. So, oh, I should put here -1 and -5. So in number 16, let's see, the vertex is at 3, -9/4, which is -2 1/4. And so my axis, A is positive, so this is going to open up. So that's going to be at 3 and then -2 1/4, so right about here. And put my symmetry line through it. this is x equals 3. So I'm going to have I'll do all my work up here for this one. I'm going to have this is opening up, so I'm going to have a minimum value of negative 2 1/4, negative 9/4. Domain, all reals. Range, y is never going to go below that, negative 9/4, so y will always be above it. Let's see. Now we need the x and y intercepts. Okay, so let's go with the y-intercept first. If I set x equal to 0 and solve for y, we'll do that down here. So y is equal to negative 1/4 times 0 minus 3 squared minus 9/4. So y would be equal to, this is negative 3 squared, which is 9, negative 9/4, let's see, negative 9/4 plus 9/4. Oh, no, wait, that's not a negative, that's a positive 1/4. There we go. So 1/4 times 9, which is just positive 9/4, and a negative 9/4. Okay, so y would be 0. So 0, 0 is the y-intercept and an x-intercept, and then I'm 1, 2, 3 to the right here, 1, 2, 3 to the left. There's my other root. So without even doing any more work on this, I know that one of my zeros is 0, and the other 0 here is 6. So those are my, so I guess I could say my x-intercepts are 0 and 6, and my y-intercept is 0. So anyway, that is the video key for page 3 of worksheet 7B.